You have two objectives to learn with this lesson. The first is A-APR.B.3, which is identify zeros of polynomials when suitable factorizations are available, and use the zeros to construct a rough graph of the function defined by the polynomial. Suitable factorizations are available. That means I will give them to you in this lesson. You've already identified zeros of polynomials in the last 2 weeks. Those are the x-intercepts. And then F-IF.C.7e or C7e, graph linear and quadratic functions and show x and y intercepts, maximums and minimums. You've already done that, but not in a factored form. Here's an example. There is a factored form of a quadratic equation. If you want it in the form that you've done for the last 2 weeks, you would multiply x times x to get x squared, x times a -3, -4 times x, simplify those, and then -4 times -3. But you must be able to graph this from a factored form. And the first thing that you're going to do is find the x-intercepts. Here's how you do it. To find the x-intercepts, you set each quantity equal to 0. x minus 4 equals 0 and x minus 3 equals 0. This is not a new set of equations. This is the easiest equation you could ever possibly solve. This is what we started out with at the beginning of this year, and you've done this in middle school. Move the -4 to the right, change the sign. Move the -3 to the right, change the sign. And there you have it. Those are the x-intercepts. If you express those as points, it would be 4, 0, and 3, 0. That means you go to the right 4 and then up 0, to the right 3 and up 0. To find the y-intercept, remember in the general form, ax squared plus bx plus c equals 0. The y-intercept was the last number and the sign before it. The way you get that last number and the sign before it is by multiplying these two numbers. So it's -4 times -3. That comes out to be a positive 12. If you express that as a point, then it would be 0, 12. The next thing is the axis of symmetry. The axis of symmetry is a line that cuts the graph into 2 equal parts. In other words, it's the x value of the vertex, which we found before, just not in this form. Come back to the top and look at this. You have 4 and 3. If the graph is cut into 2 equal parts, that means the line is going to run through a point that is exactly halfway between the x-intercept and the y-intercept. If that is the case, then you could add 4 and 3 and then divide by 2 to get the halfway point. That is 7 over 2, which is 3.5. That is the axis of symmetry. And to find the y value of the vertex, you need your equation up there, x minus 4, x minus 3. X minus 4, x minus 3. And you will plug in the x value that you just found from the axis of symmetry in for x. It is 3.5 minus 4 and then 3.5 minus 3. Evaluate that. 3.5 minus 4 is negative 0.5. 3.5 minus 3 is 0.5. Multiply those two together, and you come up with a negative 0.25. That is the y value. So to create the vertex point, you need the x value from the axis of symmetry, 3.5, and then you need the y value that we just found, negative 0.25. Next up, you have to graph it. And when you graph this, you're going to use your own graph paper that has no x-axis or y-axis on it like you see here. This is what your graph paper is going to look like. You have to put your own on there. That does not mean you automatically go down the middle and the center each time. It means you're going to zoom this graph as necessary. By zooming, it means you mess with the range. The range is, if you have an x-axis, it doesn't mean the y-axis goes down through the middle. It means it could go over here, it could go over there, whatever is necessary. Look at your information. Your y-intercept is 0, 12, so you know you have to go up at least 12. Your x-intercepts are 3 and 4. They're both positive. So there isn't much of a need to go in the negative area on the x-axis. The vertex is 3.5 and negative 0.25. You only have to go down negative 0.25, so you don't need a whole mess of graph paper that is blank at the bottom. You don't have to go down to negative 30 and such. So from this information we can gather that since we only have to go so far down on the x-axis, we can do this. We'll draw the x-axis right about here. And that will be the x-axis. And then for the y-axis, we have the rest of the page to deal with. We know that for the x-axis, we only have to go just a small amount to the left of the y-axis. So we'll try this. I could probably get a line tool out and do a lot better with that. So let's just do that, and I'll draw it like this. Probably should have been a little thinner, but I will put it right there. So there is the y-axis. And here is the x-axis. The x-intercepts are over here. We have 3 and 4. So we have to section off our graph. Each block does not have to equal 1. You can do this. I'm going to go every 3 blocks is 1. So there's 2. Here's 3. Here's 4. And our x-intercepts are at 3 and 4. Next up is the y-intercept. It is 0, 12. So we have this whole page to deal with. We can go by ones. 1 block equals 1 on the y-axis. Whatever you do for the x-axis, it must stay consistent on the left and the right. But it does not have to be the same range for the y-axis, as long as the y is consistent top and bottom. We have to go up 12. We might be able to skip every 2 on this one. Maybe. We'll see what happens. So if this were 1, that would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I think we can get in 12, yes. So there's 12 on the y-axis, and that is the y-intercept. So the graph is starting to take shape. The only other thing we need is the vertex. And the vertex from our work is 3.5 and negative 0.25. Remember that we went every 2 on the y-axis. So this would be a negative 1, that would be a negative 2. And the vertex is 3.5. That is 3.5. And we went every 2 blocks to get to 1. So if we go here, that's a negative 1. That's a negative 0.5. That's a negative 0.25. That is the vertex. 3.5, or 3.5, and then negative 0.25. The only thing left to do on this is to draw the graph. So I'll use a bigger marker. We'll go like that. It's got to go through and curve like that, and then it's got to match on that side as well. And there it is. The first thing you're going to have to do is find your x-intercepts. And to find the x-intercepts, besides needing a smaller pen, there we go, you must do the following. Set each of those equal to 0. X minus 2 equals 0, and x minus 5 equals 0. These are very simple equations. You just move the minus 2 to the right, and then move the minus 5 to the right, changing the sign in each, and then expressing them as a point. 5, 0, and 2, 0. Your x-intercepts. If you want the y-intercept, then you have to multiply these two numbers together. Negative 2 times negative 5. It is 10. Express that as a point. 0, 10. Next up, you want the axis of symmetry, which is the x value of the vertex. For the axis of symmetry, it is the point that is halfway between the two x-intercepts. So that means you're going to have 2 plus 5 and divide by 2. 7 over 2 is 3.5. That is the x value. Now you need the y value. The y value comes up when you do the following. You plug in 3.5 in for x and evaluate. That should be a 3.5. There we go. Minus 5. 3.5 minus 2 is 1.5. And 3.5 minus 5 is a negative 1.5. If you multiply those two together, you come up with a negative 2.25. That means your vertex is comprised of the following numbers. X value is 3.5 and the y value is negative 2.25. So you have your vertex, your y value, x value, your y-intercept, and your x-intercepts. Instead of using this type of a graph, you're going to use a different one. Remember, your x and y axes do not have to bisect the paper in both directions. The highest point that we have to go would have to be up 10 on the y-axis. And as far down as we have to go for our y values, it would be negative 2.25. So if we only have to go up 10, we could probably cut the y-axis axes off by 2. Every 2 blocks equals 1. But for the x-axis, our x-intercepts are 5, 0, and 2, 0. Positive 5, positive 2. So we could probably get away with the following. And I'm going to make this line a little thinner than the last time. There we go. And we will make it red. I didn't want to put that there, so we'll go back here. And the y-axis, we'll just dump it in right here and move it over. We'll put it right about there. And then for the x-axis, we have to go down negative 2.25. So let's put the x-axis right about there. So there's an x, there's a y, arrows. If your x-axis is not in the exact same spot as mine, it does not mean it is wrong. This is not a guessing game. It is for the purpose of zooming in on the graph so that we can see all of the pertinent points. The x-axis, we can mark that one off. We can space that one out by doing, let's do this. Let's do 1, 2, 3, 4, 5. I went every 3 blocks. And the x-intercepts are 5 and 2. So I'll go to 5 and I will go to 2. Here is the y-intercept. 0, 10. Okay, so I have to go up 10 on the y-axis. We haven't marked it off yet, so I am going to do this. I'll go by 2's on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there is my y-intercept. The last thing is the vertex. We have to find 3.5. So 3.5 would be approximately here. And then we have to go down negative 2 1/4. Remember, I marked off the y-axis by 2's. So there's negative 1, there's negative 2, negative 3. And again, this would be negative 1, negative 2, negative 3. We need negative 2 1/4. So negative 2 1/4. Here is negative 1, negative 2. That's negative 2 1/2. So negative 2 1/4 is right in there. That is 3.5, negative 2.25 for the vertex. We need to draw the graph. Okay, so I'll go here and use this marker. It's got to make a turn like this. Goes up and out. And this side matches it.